The sorry, where do So the graph on the left portrays the comparison between the results from the Queen's College Step Test and the multi-stage fitness test, whilst using the same group of 23 participants, all aged 18. This is done by creating a scatter graph that also shows a positive correlation between the two sets of data. The trend line acts as a good indicator for emphasizing the positive correlation in results by diagonally running through the middle of the graph. The next table on the left shows the descriptive statistics taken from the study. It shows the degree of correlation between the two sets of data by presenting an R value that is highlighted in yellow. In this case, the R value depicts a slight lean towards a strong correlation. This acts as detailed evidence towards the corresponding strong correlation, also depicted by the scatter graph. After gaining results from the Queen's College Step Test and the multi-stage fitness test, it is clear that a positive correlation has been shown between the datasets. This is since the scatter graph shows a trend line that is positive when used to summarize the average plot of data, whereas this is backed up by the descriptive statistics shown in the table as the value of 0.612666 is closer to 1 than any other value, therefore giving numerical evidence towards the two tests producing data that positively correlates with each other. However, in contrast, this evidence doesn't definitely mean that the two tests are valid, and in turn the same as the gold standard test, as it only means that they are similar to each other, consequently not guaranteeing the fact that they can be used in the same light as the gas analysis procedure. Despite this, the evidence from the results could indicate that both the methods for determining VO2 max to show that retest could show test-retest reliability. This is because they provide similar VO2 max results to each other, in turn portraying that they both ensure that consistent data is provided. It could be suggested that this is due to the fact that they use detailed and precise calculations when converted absolute values into relative. However, the the results uh, However, the results produced may still differ from a study that used the gold standard procedure. This is since there may be several issues with the methods. For instance, the multi-stage fitness test is subject to human error when trying to work out whether each participant has completed a shuttle in time when using a large sample group, in turn increasing the chance for the data to be accurate. Whereas, as previously mentioned, uh, this is much more unlikely to happen when completing gas analysis, as only one participant is participating. On the other hand, the Queen's College Step Test is vulnerable to not being the most valid procedure for VO2 max. To conclude, these points give weight to suggesting that the two tests don't truly represent VO2 max when compared to the gold standard methods. And finally, moving on to the strengths and the weaknesses. Firstly, for the Queen's College Step Test, I'm just going to zoom this out quickly. Firstly, for the Queen's College Step Test, the researcher doesn't need to be highly trained. This is because they are required to perhaps take precise measurements, complete complicated calculations, or deal with sensitive concepts relating to the participant. As a result of this strength, this test can be benefited. This is since less finances and time will have to be spent in recruiting personnel to conduct the test. In addition, this is also a strength because of the advantage it gives to the accuracy of the test. For example, as the researcher doesn't need to be extremely trained, they won't be required to take measurements that they may conduct poorly due to inexperience. As a result, the researcher has a higher chance of gaining data that accurately represents the individual's VO2 max without it being compromised. However, this step doesn't this step test doesn't directly measure VO2 max. This is because it uses an estimation to partner a calculation in determining the result. This acts as a weakness towards the test, as it means that it might not give the best representation of someone's ability to use oxygen. This is backed up by the fact that that the step test has an error rate of 10 to 20%, 20 to 20%. On the other hand, the step test is quickly completed and can have multiple participants taking part at once. Because of this, the test is benefited as it can produce more data in quicker time when compared to the multi-stage fitness test. This acts as a strength to the test because as more data is being produced to give the further strength when being generalised to a wider population. In conclusion, the step test is hindered in its accuracy. This is because it doesn't give a true measure of maximal heart rate when using an estimation. For example, the calculations for the test require the age of the participant to be taken off 220 to give their maximum heart rate. However, the health of individuals' hearts can differ, and therefore mean that this sum won't always give a proper representation. In turn, perhaps using a max heart rate is too high or too low, and to in turn damage the accuracy of the test. Whereas the multi-stage fitness test is similarly low in cost. Because of this, the researcher can spend more money on possibly more important aspects of the project rather than equipment. For example, the researcher could now spend more of their finances on hiring more researchers. This will benefit the project as more data can be gained to make a detailed analysis of the outcomes, consequently meaning that the low cost of the multi-stage fitness test acts as a strength towards it. However, the particular method requires the participant to put in a lot more work when trying to complete the test. Unlike the step test, that only lasts 5 minutes, the multi-stage fitness test relies on specific amounts of effort a participant wants to put in on the day. Therefore, the results may be vulnerable to measuring how hard the participant wanted to exercise, rather than how far they can physically push themselves, relating to how much oxygen they are able to utilize. Consequently, weakening the external validity of the test, as the result will struggle to relate to the real world. This is backed up by the fact that Kunsik 2020 stated that external validity refers to how applicable the findings are to the real world. On the other hand, a strength to the multi-stage fitness test is the equipment that the equipment doesn't need to be calibrated. This is very different to other common research methods such as the Den and enormously skin-fold calipers that need extensive effort to be applied when preparing their equipment, whereas the multi-stage fitness test merely needs a researcher to set up a tape recorder and some cones. This benefits the method as there is no need for a researcher to finance for a more experienced researcher, consequently allowing them to fund other, more significant parts of the project that need extensive thought. Nonetheless, the multi-stage fitness test is limited in terms of age ranges. For example, elderly people often struggle to fulfill their full potential in the test due to their weak stature. As a result, the test is once again responsible for measuring a concept that isn't relative to what the test is designed for. This is because the elderly people would have to stop due to possible injuries, rather than because their energy stores have depleted. And to give a proper overview of the whole slide, here it is. And that is it.